Hi guys, this is Kelsey Cameron again, and today I will explain why a cumulative ACK is used in computer networks and why it is so convenient. People didn't just create this stuff to make it a hard topic. It's actually very useful in networking, and it's an important concept to understand. So I'm going to explain this by first talking about what does cumulative mean? Well, cumulative means you continually add to something. So if I start counting, let's say I add 1, okay, my number is 1. Now let's say I add 3, okay, my number is 4. Now let's say I add 10, okay, my number is 14. I'm adding a number to whatever number I previously had. That's what cumulative means. Now let's talk about the word acknowledgement. Have you ever been talking to someone in a conversation and you ask them a question and then they don't respond? How frustrating is that? It drives me crazy personally. Acknowledgement is so important. And that's not only within human communication, but it's actually also within TCP communication. So there's something called the acknowledgement, which basically tells the other host, hey, I received this. But the acknowledgement can actually carry data, and that data is super helpful to figure out what's going on in a network. So TCP networks cannot differentiate between a loss caused by congestion or a loss caused by just a particularly lost packet. Like if a packet randomly gets lost, TCP doesn't know if it's congestion related, if it's data related. It could be so many different reasons. TCP can't differentiate between that. So this cumulative ACK will help fix those problems. So let's say my sequence number is 92, and I'm sending 8 bytes. Well, that arrow right there, this arrow, means that the data is successfully sent. And once that data is sent, that changes the next sequence number. So sequence 92 plus 8. 92 plus 8 is 100. So this value has to be 100. This sequence number means this is the number that I want you to send the data starting at. So starting from 92 through 99, those 8 bytes will be sent, and then the next sequence number will be 100. So then, after that is sent, an ACK is sent back from host B to host A, but the ACK is lost. It fails. But after that data was sent, there's an acknowledgement. Think of it as a counter. If you know what a counter is, this is going to make this concept a lot easier to understand. So every time host B actually gets data successfully, it increments the ACK. So host A sent the 8 bytes of data from that sequence number. So now, at this point, ACK is going to be equal to 100. ACK is equal to 100. So that's the first question here. What is this ACK going to be equal to? Well, the ACK is equal to 100. But then the ACK was lost. Okay, well, that's not that bad because there's a certain window of sending, and the next sequence has already been sent by the time the ACK gets lost. So there's no really wasted time. So now we have sequence 100. Sequence 100, 100 plus 20 is 120. That means that the next sequence down here is going to be 120. And that means that as soon as this data right here was successfully transferred, the ACK is going to increment again. So instead of being 100 this time, the ACK is going to be 120. So then that ACK is sent and it gets lost. Oh well, doesn't really matter. You'll see why. So the next sequence was already sent in that time. The next sequence is sent. So sequence 120, you're sending 10 bytes of data. So that means that the ACK has to increment yet again. So then at this point in time, I know that, so every time, another thing I should mention, every time the data is sent, it's actually buffered. You don't just waste data, and you don't resend things that you don't need to. So this is buffered data. So the data is already stored, in other words. So now that ACK has to increment. Your sequence number was 120. You sent 10 bytes of data and the data was successfully received. So now your ACK is equal to 130. And your ACK here, notice, is always the same as the next sequence number. So this is sequence 100 and your ACK was 100, unless the data gets corrupted. So if something happened to this link right here from host A to host B, those values wouldn't necessarily be the same. And then same here. If this link got corrupted, ACK only increments when the data is successfully received. And that's something that's core to understanding how the cumulative ACK works. So now the ACK was finally successfully sent, and we know that because this is 130, that necessarily means that everything before 130 was actually stored correctly. It means all of the data prior to 130 has arrived because it's a cumulative ACK. It only accumulates when data has been successful. So even though we lost the first two ACKs, it didn't even matter because it kept accumulating, and as soon as I received the ACK that was larger, I knew that there was just an ACK issue and that the data is actually fine. So then I get 130 back in host A right over here, and my next sequence number is 130. So hopefully you understand this now, why is the cumulative ACK important, and how this works, what's actually happening. I should also mention that in this example there was a timeout window. So this timeout was very large. But if the timeout was smaller than that, every time it times out, the packet has to be resent. If you haven't gotten an acknowledgement back from a packet that was previously sent out, you have to resend it through the timeout window. So then you can imagine how that might cause a lot of problems. If you have too short of a timeout, you're just going to waste bandwidth by sending data because you couldn't even wait long enough for the acknowledgement. It's kind of like when you go to lunch and talk to your friend's friend who just keeps talking and talking and talking, and you just kind of go along with it, and then they start repeating themselves and they don't even give you a chance to say, hey, I already heard you the first time. It's kind of like that. And then if you have a longer timer, if a loss actually does occur in the data, you have to wait forever. You can't resend that data because you don't even know it's lost until it times out. And that's a problem. You're going to waste a lot of time that you could be sending packets and actually using the network bandwidth. So hopefully that clears up a few questions on the importance of timers and what they mean. And there's actually this really amazing website, who I don't know who created it, some group of students online, but if you Google go back and selective repeat, stuff like that, online demo or something like that, it will show you live how this works with little fake packets going up and down the screen. It's kind of awesome. And it definitely helps to visualize what's actually going on. You see in that demo that as soon as it times out, the packet is resent. So the one last thing I'd like to mention in this cumulative ACK process is that if we get that same acknowledgement 3 times, so let's say I get the acknowledgement ACK equals 130, and then let's say my data starts getting all corrupted. So the ACK's not accumulating. If the ACK's not accumulating, then I know that data is not being successfully received and that there's a problem in the network, or that something got corrupted. So let's say I get three more of these. 1, 2, 3. That's 4 total. ACK equals 130. ... ACK equals 130. This is called a 3 duplicate ACK. And this means that somehow the data is getting lost. There's a data loss that's occurring, and 130 just has not been sent, and there's problems. So rather than waiting for the timer to expire, rather than waiting, there's no point, because you know that you've gotten this thing 3 more times than you already had. So a total of 4. You got the same acknowledgement 4 times, so you know that the network has tried 4 times to send this, and it's not working. So what do? You fast retransmit. This means that you skip the timer, get rid of the timer, don't even use it, and you just immediately send that sequence number of 130. So you don't wait for the timeout, you just go ahead and send it, because you know it's having problems with that particular packet. Anyway, I hope you enjoyed this video, and I hope 3 duplicate ACK, fast retransmit, and cumulative ACK makes a lot more sense now, and I hope you have a great day.